Welcome to the course on industrial automation and control. Today we are going to have lecture lesson 2, which is on architecture of industrial automation systems. Industrial automation systems as a whole are quite complex entities. If you go to a factory, you will find a bewildering array of equipment, controllers, sensors, operator displays, various cabinets containing hardware. So, all these together make a factory work like an orchestra. So, today we are going to, since it is a complex operation with various kinds of equipment which harmonize themselves with one another, before we take a detailed look at each one of them, it is useful to look at the operation of the whole system and see how the various parts relate to each other. So, that is the basic purpose of this lecture, to understand how this complex system is organized, what are the various elements in the system, how they relate to each other, what roles they perform, how they interact with each other. So, that in short defines the architecture. So, having said that, let us look at the specific instruction objectives of this course. So, since the industrial automation system, being a complex system, is definitely organized hierarchically in various levels. So, the first specific instructional objective is naturally to be aware of the various levels of industrial automation. The second objective is to describe the hierarchical structure of industrial automation systems, by which I mean that to know what these levels do, to be able to understand how one interacts with another, what information one accepts from another, and what information does it give to the other. So, that will describe the hierarchical structure, then describe the essential functions that are achieved at each level, and specifically speaking, since industrial automation is, in a sense, a lot of industrial automation actually is concerned with control, and control is of two kinds, as we shall explain shortly. It could be automatic control or it could be supervisory control. So, it is important to realize the distinction between the two. So, the last instructional objective is to understand how automatic control is distinguished from supervisory control. So, now let us look at the industrial automation pyramid as a whole. Why is it a pyramid? It is a pyramid because there are several levels. So, it has a vertical dimension. So, we have the lowest levels of sensors and actuators which directly interact with the process or the machine. So, they actually get the signals from the process of the machine. Now, these sensors and actuators are actually act as the eyes and the arms of the controllers. So, on top of these we have the automatic control layer, which is called level 1. Now, a number of automatic controls are again managed at the supervisory control layer, which we call level 2. Finally, the operation of a particular shop floor as a whole is controlled, the whole overall manufacturing operation, including maintenance, production, quality assurance, inventory, everything is managed at another level which is called production control. And finally, right at the top we have enterprise control, which is more like a, I mean basically consists of management functions, where not only the production related operations are considered, but even other operations like sales, marketing, new product development, everything is considered, and production is considered just as a part of it. That is level 4. Now, at this point I should mention that while these functionalities are necessary for the overall control of a factory, but it often turns out that not necessarily all these layers are perfectly automated. What I mean to say is that generally sensors and actuators must be automated, there are equipment for it. Automatic control layers are also automated, there are most operations are not manually controlled, but from the supervisory control layer upward, it is not always true that you have computer based automation for functioning for performing the operations of that level. In fact, some of these operations may very well be done by human beings. For example, if you go to a power plant, or if you go to a big refinery, you will find that invariably on the shop floor you will have a control room. If you enter the control room, it is usually a very large room, where in the center of it you are very likely to find that there are a number of large computer monitors, and there are a group of people who are actually sitting around these monitors and constantly looking at these. So, they are generally the process supervisors or the operators who perform a lot of supervisory control functions. So, at the supervisory control level, there could be some functions which are automated, while some functions could be performed manually also. At the production control level, most of the operations, most of the time, are performed by humans with the aid of tools which help people perform the production control functions. So, that is why we have what is known as a production manager, or say in a power station we have a shift charge engineer who is in charge of running the overall power system, overall power plant for a certain duration of time. So, this production control functions are invariably a mix of manual as well as automated tools. Similarly, enterprise management functions are also like that. You have managers who use tools for performing their functions. So, we have level 0, level 1, level 2, level 3 and level 4. Now, having said that, let us look at these levels and their natures with a certain some more detail. So, first of all, we would like to point out, and this is why this system is called a pyramid, is because that as you go up the pyramid, the spatial scale and the temporal scale or the time scale of a given system at that level increases. Now what do I mean by that? So, for example, consider one sensor system. One sensor system measures one process variable in the whole machine. So, it looks at only that variable. So, in that sense, its spatial scale is actually related, is actually very limited. So, in the whole shop floor there are several machines. In each machine there are several process variables, and the sensor which is at level 0 only looks at one of them. So, in that sense it is spatially, its scope is very limited. Similarly, but its interaction is over a very small time scale, that is, it gives over sampling times, it gives values to the controller. So, each value represents the variable over a very short time. So, in that sense it has a very each value which comes out from the sensor has a very short time scale. Now, as you go up, for example, if you go to automatic control also works at the sampling level, in the sense that it computes control inputs for the plant at each sampling point. But while it is designed, sometimes considerations are made of larger duration. For example, when you say that the settling time should be low. Now, when you are considering settling time, you are actually considering that if you make a step change, then from one operating point to another, how does the output reach from one level to another. So typically you are concerned about a duration of time which spans over several sampling times, right. So, if you go to supervisory control level, one of the major functions is to change the set point, and set point changes are not made every moment. Control input changes are fed to the plant every sampling time, but set point changes are not made every sampling time. Definitely they are made over let us say typically some hours. If you take a power system boiler, so it will be say at 3 o'clock in the night, it may be operating at 10% load, at 7 o'clock in the morning it may be operated at 25% load, at around 9:30 there is huge amount of load comes in the power system because all the offices open up and things like that. So, between 9:30 and 11 o'clock it will ramp up significantly from, let us say, 30% load to nearly 90% load perhaps. Then that 90% load it will maintain till again, say, let us say 5 o'clock. After about 5 o'clock it will, evening will come and people will switch on various kinds of lighting loads. So, then you will get the evening peak load. So, only when the load will significantly increase will the boiler operating point be changed, right. So, the operating point of a boiler typically gets changed let us say 7, 8, 10 times over a day, and its change is also based on the decisions for change are taken based on periods of hours, right. So, in that sense it is on a larger temporal scale. It is also on a much larger spatial scale, because one sensor looks at one signal. One automatic controller may be taking control action taking several sensors into account. So, in that sense its spatial scale is now increased. Now, one supervisory controller will typically look after a number of automatic control loops, and it typically looks after one piece of equipment like a boiler or a furnace or a distillation column. Typically they will have many automatic control loops. Similarly, a shop floor may be made of several such units or machines. So, the production control is done typically at the shop level, while the enterprise control is done at the overall enterprise level. So, as you go up you can understand that the time scale is increasing and the spatial scale is also increasing. That is why it is a pyramid and not a cylinder. If you look at, so having clarified that, let us look at the nature of technology which is used for automation at these various levels. So, at the lowest level, when you have sensors and actuators, so here you have mostly hardware. Things are, either they are actual sensing elements, or they are packaging elements, or electronic circuits, or microprocessors. They are generally very hardware oriented. Nowadays we are also having software along with that, but the software is also very close to the hardware, in the sense that they actually interact very close to the hardware and they are written specifically for that hardware. So, in that sense we have a lot of what is known as embedded technology at this level. So, this word embedded is because it is the kinds of, actually the sensor is supposed to be embedded in the machine. So, all the this technology uses embedded hardware and software. When you go to the automatic control level, then it happens in many cases that it's a separate hardware. It is not embedded into the process, into the machine. It is a separate, tangibly separate piece of hardware which runs real time software. The software is generally generic, it is not very special purpose, but it runs on, often it runs on special purpose hardware like like PLCs, industrial PCs or some DSP processors. So, but the algorithms are generally generic like a PID control. PID control is a very generic control algorithm which is used for a number of process control applications, but the software is real time in the sense that outputs must be generated within a given amount of time, because every sampling time you have to generate the control inputs to the plant. So, you have real time software, hardware is special purpose or general purpose, both are possible. If you go to supervisory control, you will find that hardware is mostly general purpose, it's general purpose computers, of course with a strong data interface, because lots and lots of channels of data from the whole process come to this. The software is still online because the difference between what is a piece of software is called online if it interacts with the external world. So, it works on the data which is continuously streaming in from the process using sensors and various communication channels, but it is not very hard real time. By hard real time an application, a software application is called hardware real time when the execution must be finished within a time deadline. If it does not finish, then serious consequences may occur and the system may fail. But these generally work, are generally a mix of mostly soft real time in the sense that, well, things must be done in time, but they are not so hard, that is if one does not one particular piece of computation cannot be finished in time, then some performance degradation may result, but in general the system as such will not fail. For example, one of the main purposes of this supervisory control layer is to update the man machine interface, that is whoever is the operator, he has to be shown how the process is performing, plot the graphs, plot various statistics, etc. So, these are typically soft real time operations in the sense that obviously you cannot display a variable 30 minutes after you have got it, right, but as long as you display it in time, whether you are displaying it within 2 seconds or whether within 10 seconds is not of much consequence. So, to that extent it is called soft real time. Software is, the hardware is general purpose, but the software is very special purpose, that is supervisory control software for a refinery will be completely different from that of a power plant, which will be completely different from that of a let us say a manufacturing plant. So, they are very specific to the machines, the software, but the hardware is general purpose. Production control does not bother about machines as such, they are not really concerned about, they take an abstract view of the factory, how many pieces of equipment are being produced per hour, whether that piece of equipment is actually whether it is a gear or whether it is an engine box or whether it is nuts and bolts, it does not matter. So, machines are looked at as general purpose service providers or material transformers. So, you give a milling machine a blank, it will produce a gear. So, what is the exact technology of the milling machine? It is not of interest at this offline level. What is of interest is how many pieces of parts it can produce, whether it is functional or whether it is non-functional, such things, right. So, the software is generally offline and it does use various kinds of algorithms, but they are of a totally different nature and they are not concerned as such with the machines themselves, but take an abstract view of production. Similarly for enterprise level. So, at these two levels and to some extent at the supervisory level, we are not so much close to hardware, that is we look at the process as an abstract entity and we take decisions about them and we analyze the performance, we also monitor them. So, in that sense the layers up to from some parts of supervisory control as well as production control and enterprise control, I would like to term them as industrial information technology rather than industrial automation technology. You know, automation has a kind of hardware flavor. It has a kind of hardware real time software kind of flavor. So while industrial information technology also contains lot of technology, resource optimization technology, scheduling technology, etc., but they are not concerned so much about hardware, they are generally generic technologies and they are non real time. So, in that sense I would like to distinguish between industrial automation and industrial information technology. So, in this course we will take predominant focus is on this, on the first 3 layers. We will see layer 1 and layer 0 very in some depth. We will also look at some automation technologies which are now being deployed for supervisory control. So that now another thing that needs to be said is that these layers actually exchange information. So sensors are continuously collecting samples of measurements which they are passing over to automatic controller. Similarly, the automatic controller is continuously computing control inputs which they are passing over to the actuator. Now, similarly, the information that the sensors and actuators are that the automatic controllers are receiving from the sensors, part of it they are actually passing to the supervisory control layer to see whether the control loop is working satisfactorily or whether some set point change is needed. So, or whether there is some malfunction, some sensor has failed and the process output is going out, in which case the supervisory controller must take some action. So, it can either change the set point, or if there are 2 sensors it can switch from one sensor to the other. So, it gives commands. So, you can see that there is continuous information flow from the lower level to the upper and from the upper level to the lower, and as information goes up, because of the spatial and time scale, information continuously gets aggregated up. So, you as you go higher and higher, you get more and more time averaged information over a part of the factory. As you come lower and lower, you get more and more detailed information about a smaller and smaller part of the machine. So, as you go up, information gets aggregated, as you come down, information gets resolved. So, there is resolution or refinement occurring. Okay. Now, how do all these information flow up and down physically? How do they transmit? So, nowadays I mean lot of stress is being put on. So, there is usually a communication system which actually connects all these devices so that they can seamlessly exchange information, send results, in fact do lot of configuration management, various kinds of things. So, there is a if you see the industrial automation market, you will find lot of activity here and some new trends emerging in the factories which we will review in the course. So, having got this kind of an idea about the overall industrial automation system, we would like to take a look at now we will like to take some more detailed look at these various levels, and before we do that we must understand that much of this technology, much of the part of industrial automation that we are going to concern ourselves with is actually about control. So, we should first see what are the elements of industrial control. So, the structural elements. So, what is basically done in control? Why do we control? We control because we want that the outputs or some process related variables, which could be temperature, which could be pressure, or we want them to behave in certain ways that we desire.